Alright, let's do this first. So you're gonna have to get fairly good at putting things in slope intercept. And remember, possibly, you remember that slope intercept form is y equals mx plus 2. So if I have 2x minus 3y equals 12, and I want to solve this for x, or for y, the best thing to do is to go ahead and start thinking about putting these things in slope intercept. So the first thing I'm going to do is move this 2x over. So then we have negative 3y equals, and I'm going to put this in front of this, negative 2x plus 12. And then finally, to go ahead and get y by itself, if I divide everything by negative 3 on this side, I divide everything by negative 3 on this side. So then y equals, this negative divided by that negative is positive, so I have 2 over 3x minus 4. Alright, so then if we are graphing these, then if we go ahead and set up a table, alright, we'll set up our table, and we'll come over here and we'll set up a graph. Alright, so we have the domain as negative 10, negative 5, 0, 5. Alright, so I'll plug in negative 10 for x. Negative 10 times 1/5 is negative 2. Negative 2 plus 1 is negative 1. Negative 5 times 1/5 is negative 1. Negative 1 plus 1 is 0. 0 times 1/5 is 0 plus 1 is 1. And of course, we can kind of fill this out the rest of the way. We're adding 1 each time, so this is likely 2, and this is likely 3. So we have, let's say, negative 10, negative 1, put a point there, negative 5 and 0, put a point there, 0 and 1, put a point there, 5 and 2, put a point there, and positive 10 and 3. And remember that, again, this is something that I'm getting ready to make a mistake on. We're not connecting these. Okay? This is a discrete function. This is just for these values of x. So these are just these points right here. All right, so what makes a function a function? Okay, good. All right, so the x goes to 1y. It'll be the same y. Okay, it only goes to 1. All right, what else? If I'm looking at a graph, how do I know it's a function or not a function? Good. Okay, good. So therefore, we just hit those two levels. All right, good. So if each element of x is related to exactly one element of y, and graphically, if it passes the vertical line test, it's a function. Okay? So those are the two ways we have talked about whether or not it's a function or not. What makes it linear? What makes it linear? Put it on the graph. Okay? All right, good. So, is this a function? Yes. Is it a linear function? Yes. Okay. Is this a function? Yes, it's a function. Is it a linear function? No, it is not a linear function. Is this a function? Is it a linear function? Oh, on the test. That's not a function. Okay? This is not a function, but it is linear. Okay? And I kind of worded that wrongly. It is not a function, but it is linear. Is this a function? No. Is it linear? No. All right, so when you are looking at a table of values, you may have to create a table of values in order to be able to determine whether or not it's linear or not. Okay? Linear slope in particular is constant. Okay? So if my change in x values is the same number, and my change in y values is also the same number, then this is a linear function. Okay? So if I look at this right here, table of values, my change in x is the same, but my change in y is not the same. Now, as we move into this section right here, I want you to realize that when we start to, and I'm not sure if you guys have touched upon slope before, but slope is the change in y over the change in x. So in this case, if I was looking at this table of values, my change in y is -3, my change in x is 1, so my slope is -3. Okay? If this was not linear, so I want you to fill this table out. I want you to tell me whether or not it is a linear function or not. Is this a linear function or not? It is, okay? Because our change in x, each time, we're doing what? Adding 4. And our change in y each time is what? Adding 3. What's my slope? 3/4. Okay? Alright, so I'm not going to make you guys do the next one here. So let's talk about standard form of linear equation. Okay? Standard form of linear equation is some number times x plus some number times y, and it equals c. Okay? Now, let's just kind of talk about something here for a second. If I'm looking at this x right here, this x has an exponent, and this y has an exponent. What is that exponent? You know what the value of it is? 1. Okay? The value of this exponent is 1. Remember that x to the 1 power is just x. Okay? When we have a variable by itself, we assume two things. One, that the exponent is 1, and one, that the coefficient is 1. Okay? Alright, so it is not a linear function if any exponent is greater than 1. It is not a linear function if any of my variables are multiplied together. It is not an exponent if I have a negative exponent or variable in denominator. Now I put this on the same line for a reason. Because if I have x to the negative 3, well, we're going to learn later on in this unit that that's the same thing as 1 over x to the positive 3. Okay? Nope. Okay. But that's why I put both of them here, because both of them are the same thing. In this case, I have a negative exponent that disqualifies it from being a linear equation. And here I have the variable in the denominator that also disqualifies it from being a linear equation. So, this is kind of a rule. Is a linear function. It is not a linear function. I'm not going to graph that. Is this a linear function? Is this a linear function? Why? I will put it. Is this a linear function? Is this a linear function? Yes, it is. Okay? Now, I left off this right here. Go back to these rules. You cannot have a variable in the exponent. You really need to add a fourth one down. It says no variable